In 1952, a programmer named Grace Hopper built the first compiler, a tool that translated human-readable code into the machine instructions that then ran on the hardware. The reaction was vicious. Real programmers wrote machine code, the critics said. Compilers were for people who weren't smart enough. They'd make us lazy. They'd make us forget how to actually program. Sound familiar? That same argument has played out every generation since. High-level languages, IDEs, garbage collection, autocomplete. Every time the tools take over more of the work, a portion of the field swears it's the end of real engineering. In 2026, we're having the exact same argument about AI code generators. Same energy, same arguments, just with 60% more Hacker News comments. Except this time, adoption hit 84% of developers before the argument was even resolved. Whatever you think about whether this should be happening, it already happened. So let's skip the argument. In the next 10 minutes, I'll tell you what AI code generators actually are in a way that finally makes the whole category click. Why developers are simultaneously the most productive and the most nervous they've been in 15 years. And how to spot the difference between a tool you'd let near production and one that's about to embarrass your team in front of your CISO. Here's the reframe that fixes everything. AI didn't learn to write code, it learned to translate it. Software has always been a translation problem. You start with what you want, and that is your goal. You translate that into formal logic, then into code. Then the machine translates the code into instructions it can execute. Every generation, the tools got smarter. Assembly languages handed off some work, high-level languages handed off more. IDEs with autocomplete handed off a little more. AI code generators are the next step. They translate directly from natural language, from what you want into code. Assuming your natural language is more, return a paginated list of users matching this filter sorted by created _ @desk, then just make it work. That's the whole category in one sentence. Everything else flows from this. Here's the engine inside. A large language model, an LLM, is trained on enormous amounts of existing code, mostly open source repositories. The model learns the patterns, how Python loops look, how REST APIs get called, how Java classes are structured. Billions of examples. The model has read more Python than any human alive, and also more abandoned side projects than any human alive. So when you type, let's be concrete, write me a function that takes a city name and returns today's weather forecast. The model doesn't think about it the way you do. It finds the most statistically likely continuation. Based on every similar example it's ever seen, it predicts this is probably what the code should look like. 2 seconds later, you have a working function. Doc string included. That word matters. It doesn't know, it predicts. And one detail people miss. This engine runs in both directions. Handed a 400-line function nobody's touched in 5 years, ask what it does. You get a plain English explanation. Hand it COBOL, you get Java. Hand it broken Python, you get fixed Python. The translator goes whichever way you point it to. The reason 84% of developers use these tools is that the translation actually works. And the impact lands at tool levels. For the individual developer first. The average developer reports a 35% increase in productivity. 3.5 hours saved per week. Picture what that looks like. You inherit a service nobody has touched in 3 years. Used to be 2 days of reading code before you could even start. Now it's 20 minutes of asking the model what's happening and reading its explanation. It's 2 a.m., you're debugging production, and you can't remember the syntax for a Kubernetes manifest. To be fair, nobody remembers the syntax for a Kubernetes manifest. That's why these tools exist. Boring work gets handled. The boilerplate, the JSON parser you've written 15 times, the regex you used to lose an hour on Stack Overflow finding. It's gone. You spend your time on the parts that actually require human judgment. And that is architecture, design, and the hard trade-offs. 55% of developers say they're more satisfied with their job because of this, which is wild. Engineers are not historically a satisfied population. But the team-level impact is even bigger. Here's our team. Junior developers level up faster. Pairing a junior with an AI translator is like giving them a senior engineer available 24 hours a day. One who never sighs when they ask a basic question. Smaller teams ship more. A 4-person team in 2026 credibly does the work that used to require 8, half of which used to be spent in stand-up explaining what they did yesterday. And maybe the most important one, code reviews change. They shift from, did you use var instead of let, to, did you make the right design choice? The amount of pedantic style nits dropped by 60%, which is its own productivity gain. This is the dream. This is why every major engineering org is rolling these tools out. But here's where it gets interesting. Translation isn't the same as understanding. 55% of AI-generated code contains security vulnerabilities. That's a Veracode finding from 2025. AI code is 1.88 times more likely to introduce vulnerabilities than human-written code. And, this is the one that surprises people, only about 30% of AI suggestions get accepted. Even developers who love these tools reject 70% of what they produce. Let me show you what that failure looks like. You ask for a function that takes a user ID and returns account info. The model generates a beautiful, clean SQL query with all the SQL injection prevention of a 2008 PHP tutorial. String concatenation, complete with helpful comments explaining the variable names. It passes your tests. It also has a vulnerability a junior developer in 2010 would have known to avoid. You ask for an authentication function. Looks great. Logs users in, stores their sessions, stores their password as a plain text, with a comment explaining why this isn't ideal. The model knows, it just doesn't care. The phrase to remember here is the illusion of correctness. AI code looks right, clean syntax, sensible variable names, but it can be subtly, deeply wrong. And that subtlety is exactly what makes it dangerous in production. It's the technical equivalent of a really confident LinkedIn post. So the productivity gains are real. And the risks are real too. The translator's job isn't done when the code is generated. It's done when a human has reviewed it. Which brings us to the real question. Not do I use an AI code generator, but which kind? Think about translation in the real world. If you're at a restaurant abroad and you want to ask where the bathroom is, your phone's free translation app is fine. Stakes are low. Speed matters. But if you're translating a legal contract, a medical diagnosis, a Kubernetes manifest, you don't use the free app. You hire a professional translator, one who's certified, who specializes in your domain, who you can hold accountable. AI code generators split the same way. On one side, we have general purpose AI code chat assistants you sign up for in 2 minutes. Great for quick drafts, great for exploration, trained on whatever they could find on the internet. No visibility into where any individual suggestion came from. Your code leaves your environment to get processed. On the other side, we have production-grade AI code generators trained on curated data, customizable on your team's code and standards, integrated into your development workflow. Your code doesn't leave your infrastructure if you don't want it to. The line between them is trust. And trust comes from 3 questions. Where did the training data come from? Where does my code go when I use the tool? And can I audit what happened? Free translators don't have great answers. Professionals do. When mature engineering organizations talk about enterprise grade, they mean 4 things. The first one being provenance. You can trace where a piece of generated code originated. That's critical for IP, licensing, and audit. It becomes important the day a junior ships AI-generated code into your monorepo and your legal team starts asking whether it's GPL tainted. The second one is governance. Policy enforcement on what the tool can and can't do, and audit trails for compliance reviews. The third one being on-prem or hybrid deployment. Because for HIPAA, for SOX, for the EU AI Act, your code and prompts cannot leave your infrastructure. We pipe PHI to SaaS endpoint is not a sentence you want appearing in a post-mortem. And then there is curated training data. Pre-trained on permissively licensed code, not just whatever was scraped off the internet. The training set is part of the trust posture. This is the difference between a translator who can order your coffee and a translator your legal team won't fire you over. An AI code generator turns natural language into code. That's just the definition. But a good one turns natural language into code you can ship, code you can audit, code that doesn't surprise you at 2 a.m. in production. By 2028, 90% of enterprise developers will be using one of these tools. The question isn't whether your team adopts them, it's which translator they trust.